In this module, you will learn about latent heat. Matter normally exists in three states: solid, liquid, and gas. A transition from one of these states to another is called a change of state. Two common changes of states are solid to liquid and liquid to gas, and vice versa. That is, from liquid to solid or gas to liquid. These changes can occur when the exchange of heat takes place between the substance and its surroundings. That means when a solid is to change to liquid or liquid to gas, there has to be some form of heat involved. The change of state from solid to liquid is called melting, and from liquid to solid is called fusion. That means when a solid changes to liquid, the process is known as melting, but when liquid changes to solid, then it is known as fusion. It is observed that the temperature remains constant until the entire amount of solid substance melts. That means when we have a solid and it is changing into liquid, in this process, if we have a thermometer there, then it will not record any change in temperature. That is, the temperature remains constant. That is, both the solid and liquid states of the substance coexist in thermal equilibrium. During the change of states from solid to liquid, the temperature at which the solid and the liquid states of the substance are in thermal equilibrium with each other is called its melting point. This melting point is the characteristic of the substance, but it does depend on pressure. Now, let us consider a situation when we have ice at minus 20 degrees Celsius. Now, if heat is added to this ice, which is at minus 20 degrees Celsius, the temperature of ice will increase. Till when? Until it reaches its melting point. And what is the melting point of ice? 0 degrees Celsius. So when we heat ice from at minus 20 degrees Celsius, then its temperature will continuously rise till it attains 0 degrees Celsius. So 0 degrees Celsius is the melting point of ice. So it will reach that temperature, and at this 0 degrees Celsius, the addition of more heat will not increase the temperature, but will cause the ice to melt, or I can say change its state. Once the entire ice melts, there would be only water now. Adding more heat will cause the temperature of the water to rise till water reaches its boiling point, which is 100 degrees Celsius. So children, what is it implying? What we are trying to say is that when you heat ice whose temperature is below 0 degrees Celsius, then its temperature will rise till 0 degrees Celsius, which is the melting point of ice. So at that temperature, ice will start changing into water till the entire ice becomes water. Then the temperature of water will rise from 0 to 100 degrees Celsius, and at 100 degrees Celsius, since it is the boiling point of water, the water will start changing into steam. Adding more heat to boiling water causes vaporization without increase in temperature. The process of heating of ice till it converts into steam can be represented graphically by this graph. Now over here, you can observe that you have, we have taken x's on the y-axis, recorded temperature is being noted, and on the x-axis we have the heat given. Now initially ice was taken, which was at minus 20 degrees Celsius, and it was heated. So the heat that was given to the ice raised its temperature till 0 degree Celsius. So finally, the heat given, we can say, is raise the temperature of ice, and here at this place, if I mark it as A, I have A, ice at 0 degree Celsius. Then we find that there is no change in temperature, and this point B, from A to B, there is no change in temperature. So at this process, when we will observe during that, here we will have now water. So in this situation, ice is getting converted into water, and at B we have only water which is at 0 degree Celsius. Then the temperature of water rises. We achieve this point C. At C, there is water at 100 degree Celsius. So, from B to C, there is a constant rise in temperature of water from where? From 0 degrees Celsius to 100 degrees Celsius. At 100 degrees Celsius, when water has attained 100 degrees Celsius, again there is no change in temperature. And at this point, we will have only steam at 100 degree Celsius. So basically, between C to D, there is no change in temperature. So what is happening during this duration? Water is getting converted into steam. So let's review this whole thing once again. What we basically have is that when we heat ice, which is at a temperature lower than its melting point, it can be any temperature. We have taken minus 20 degrees Celsius, and when ice at minus 20, I am telling you it could have been any temperature, but when ice at minus 20 is heated, first of all, what happens? The temperature of ice rises from minus 20 degrees Celsius to 0 degree Celsius. Then from at 0 degrees Celsius, the conversion of ice takes to water, and we get water at 0 degrees Celsius. So basically during this process, melting of ice is taking place, and there is no rise in temperature. When the entire ice gets converted to water at 0 degrees Celsius, again there is what? Rise in temperature of water. So the temperature of the water rises from what? 0 degrees Celsius to 100 degrees Celsius. Now 100 degrees Celsius is the boiling point of water. At this stage, we'll find that there is no change in temperature, and the water continuously gets converted into steam, and finally we'll have steam at 100 degrees Celsius. So once the water attains 100 degrees Celsius, then water at 100 degrees Celsius gets converted to steam, which is at 100 degrees Celsius. So whenever the change in state is taking place, there is no change in temperature. You can observe that there is no change in temperature. So children, when a substance changes phase, that is, it goes from either a solid to a liquid state or liquid to gaseous state, it requires energy to do so. This energy that is required to change the state is given a name as latent heat. Now, you have seen in the situation, this heating of the ice situation, latent heat does not raise the temperature, but it has always to be supplied to change the state of the substance. Without it, the state will not change. That means the solid cannot get converted to a liquid or liquid cannot get converted to a gas. Now this word latent means hidden. It is called latent heat because it becomes hidden in the substance undergoing the change of state and does not show its presence by raising the temperature. The latent heat which we supply is used up in overcoming the forces of attraction between the particles of the substance during the change of state. So what I mean to convey over here is that this heat which is being used to change the state is known as latent heat because it is hidden, because the thermometer is not indicating any rise in temperature. Then what does this heat do? This heat is basically helping to overcome, or it is overcoming the forces of attraction between the particles of a substance. That means when we take ice, we heat it, then this heat is overcoming the force of attraction between the ice molecules, increasing the intermolecular distance. So finally, the water starts getting converted into ice. Basically, you know the difference between the ice and water is only between the arrangement of their molecules. So remember, this heat is only overcoming the forces of attraction between particles of a substance during the change of state. So we can say that the latent heat does not increase the kinetic energy of the particles of the substance. And since there is no increase in kinetic energy of the particles, the temperature of the substance does not rise during the change of state. I hope you can recall that temperature is directly proportional to kinetic energy. And since the kinetic energy is not increasing, obviously the temperature will not increase. So if you go back to this graph once again, you will find that there was a place where you had no rise in temperature. So when the ice was heated from -20 to 0 degrees Celsius, so there is no rise in temperature. Why? Because there is only a change in state from ice to water. Similarly, at this 100 degrees Celsius, there is no rise in temperature after that. Why? Because water is getting converted into steam. Heat required during a change of state depends upon the heat of transformation and the mass of the substance undergoing a change of state. Thus, if if m is the mass of the substance and it undergoes a change from one state to another, then the quantity of heat required is given by Q is equal to mass into L, where L is the latent heat and it is a characteristic of the substance. The SI unit is joule per kg. As you can see, when we say that Q is equal to M into L, then we can have L equal to Q upon M. The SI unit of Q, that is heat, is joule, whereas the SI unit of mass is kilogram. So the unit becomes joule per kg. Apart from this, there are other units also, like we can express latent heat also in joule per gram. And you all know that commonly used unit for heat is calorie. So we can even express latent heat as calorie per gram, or it can also be kilocalorie per kg. But remember, the SI unit is joule per kg. The value of L also depends on pressure. Its value is usually quoted at standard atmospheric pressure. The latent heat for a solid liquid state change is called latent heat of fusion. Basically, the substance changes from solid to liquid or liquid to gas, then it requires heat. So, when it changes from solid to liquid state, then we call it as latent heat of fusion. And when there is a change in state from liquid to gaseous, then we call it as latent heat of vaporization. Let's define specific heat of fusion. Amount of heat energy absorbed or released by unit mass of substance to change a state at constant temperature. So basically, when we were talking about ice converted into water, then we need latent heat. But when water gets converted into ice, then this latent heat is released, but the temperature remains constant. So just let's recall that Q is equal to M into L, and when we will talk about L, then L will be equal to Q upon N. You already know the latent heat unit will be joule per kg. Now, the latent heat of fusion for ice in SI system is 3.36 into 10 to the power of 5 joule per kg. I hope you can realize this number is very large. In commonly used units, the value of latent heat of fusion for ice is 80 calories per gram. When ice melts, then the heat is required. But when water freezes, then heat is released. Now, the fact that latent heat of fusion for ice is 3.36 into 10 to the power of 5 joule per kg. What does this mean? It means that 1 kg of ice at 0 degrees Celsius requires 3.36 into 10 to the power of 5 joule of heat for completely changing into 1 kg of water at 0 degree Celsius. But when 1 kg of water at 0 degrees Celsius freezes, then it releases 3.36 into 10 to the power of 5 joule of heat energy to change into ice at 0 degree Celsius. So when ice will get converted into water, it will require heat. It will absorb heat. And when water converts into ice, it is going to release heat, maintaining constant temperature in both situations. Now, remember that 1 gram of water at 0 degrees Celsius has 336 joules heat energy more than 1 gram of ice at 0 degree Celsius. Now, let's see what are some physical phenomena based on high value of specific latent heat of fusion of ice. During winter season, lakes and ponds do not freeze all at once. Do they? No, they don't. Why? Since specific latent heat of fusion of ice is high. You already know that ice requires a large amount of heat. So, a large amount of heat is to be withdrawn from water at 0 degrees Celsius for it to freeze. So, if the lakes and ponds have to freeze, then a large amount of heat has to be extracted from that water to convert it into ice. So, whole lake does not freeze all at once. Secondly, when ice is in a frozen lake starts melting, the surroundings become very cold. Now, when ice in the frozen lake starts melting, then 1 gram of ice absorbs 336 joules of heat energy from the surrounding atmosphere. As a result, temperature of the surrounding falls and it becomes cold. Snow on high mountains does not melt all at once. Had it would been, the plains would have been flooded. Now, during summer, when temperature rises, snow melts. But due to high specific latent heat of fusion of ice, snow melts at a slow rate. As a result, water flows around the year in the rivers. When is it cold? After a hailstorm or during the hailstorm? Obviously, after a hailstorm. During hailstorm, 1 gram of water releases 336 joules of heat energy to the surroundings to change into 1 gram of ice, resulting into increase in temperature of surroundings. Whereas after hailstorm, 1 gram of ice absorbs 336 joules of heat energy from the surroundings to change into 1 gram of water, resulting into decrease in temperature of surroundings. So you see, when the snow is being formed, then basically at that time the heat is released to the surroundings. But when the snow melts, then heat is extracted from the surroundings. So, though it is cold when the snow is formed, but it becomes much colder when the snow melts. Now, what would you prefer to cool your soft drink? Ice cold water or ice cubes? Definitely ice cubes. But why? Because 1 gram of ice at 0 degrees Celsius will absorb additional 336 joules of heat energy from the soft drink than 1 gram of ice cold water. So ice will absorb additional heat in form of latent heat from the drink in comparison to ice cold water. So it is going to cool the soft drink more effectively and quickly.